Hi, welcome back to another video. So today we're going to be talking about power rules. So let's just start. Basically, all you need to know is that there are some rules, you have to adhere to them, and it's actually a really simple chapter. So let's say that we have a to the power of n. So a is a real number, and n is, well, it can be any number really. It can also be a real number. So let's just say a and n are both reals. Okay, so n and a are both real numbers. Now, what are the rules? So, and let's also say that m is a real number. A to the power of n times a to the power of m is going to be equal to a to the power of n plus m. What's the logic behind it? Well, let's say that we have 2 to the power of 3 times 2 to the power of 2. We're going to have 2 times 2 times 2, and then times 2 times 2. So this is 2 to the power of 3, and this is 2 to the power of 2. So basically you just add the powers together. And for another example, for the general case, a to the power of n times a to the power of m, we're going to have a times a times a, etc. times a, and that's going to be n times. And then we're going to have a times a times a, etc. times a, and that's going to be m times. So together it's going to be n plus m. Okay, that's the first rule. The second rule is a to the power of n divided by a to the power of m. In that case, we have, instead of addition, we have subtraction. So we are going to have a n minus m. And because you know that fractions are the same as division, the same rule applies for fractions. So a to the power of n divided by a to the power of m is the same thing, because fractions and division are equivalent operations. Now, there's a special case here, and the special case is, and also the logic behind it. If you imagine you have a times a times a times a, etc., and you have it, let's actually say like this, n times, and then you have a times a times a times a, etc., and you have it m times. Well, they're gonna cross, so or reduce. So we can reduce this a, and then this one, and this one, and this one, and this one, and it's so on. So what remains if you have, for example, a to the power of 5 divided by a to the power of 3? Well, you're gonna have a times a times a here, and a times a times a, and they're just gonna reduce. And we have a to the power of 2. Now, the thing that can be a bit nuanced here is, what if there's the same number at the top and at the bottom? So a to the power of 2 divided by a to the power of 2, a times a divided by a times a, that's going to be equal to 1, because it's a reduced fraction. So, and if we use the formula, a to the power of 2 minus 2, so here we used this rule, okay, is a to the power of 0. And we get our new rule. So any number to the power of 0 is equal to 1. There is an exception, however, and that number, the exception, is going to be 0. Why? Well, 0 to the power of 0 is not equal to 1, because it would imply that we divided by 0. It would imply that we had 0 times 0 times 0, and then here in the denominator we also had 0 times 0 times 0, which implies division by 0, and we've already said that any number divided by 0 is undefined. Okay? So, that's basically the rule for the division. So, these are the two rules. Now, let's talk about powers. So if we have a to the power of n to the power of m. Now this should not be mistaken with and this is very important, so we're gonna mark it with red, okay? This should not be mistaken with a to the power of n to the power of m, okay? So this parenthesis, like the placement of the parenthesis is really important here, because for this one we have a rule, for this one we do not. 2 to the power of 2 to the power of 2 has a rule, okay? And then 2 to the power of 2 to the power of 2 does not have a rule, okay? So this one does not have a rule. Okay, I think I picked a bad case because I think in this case they are actually the same, but in a lot of other cases they wouldn't be the same, okay? So what do you need to know about this? Yeah, for example here, okay? If instead of this 2 we just use 3, okay? Let's see. 2 to the power of 2 is 4. 4 to the power of 3 is going to be 64. 4 times 4 times 4, okay? Now, we have 2 to the power of 3 is 8, okay? So we have 2 to the power of 8, and then 2 to the power of 8 is 256. So you see how they're not the same, okay? Now, what is the rule? If you have this example, so a to the power of n, and then that power is raised to the power of m, you have a to the power of n times m, okay? So these rules are for plus and minus. This is the first product rule that we have, okay? And what you need to do, and how we can explain it, is imagine that you have a times a times a times a, okay, and you have it n times. And then you have times a times a times a, etc., and you have it another n times, okay? And this just repeats. How many times does it repeat? It repeats m times, okay? So we just wrote this out, okay? So how many a's do we have? Well, we have m times n a's. So that's why we get this formula here. Now, that's for the power, and then another thing, if we have a times b to the power of n, that's the same as a to the power of n and b to the power of n. So it basically distributes. Lastly, let's talk about some other things. So for example, from this division rule, we said what happens if we have 0. We can also determine what happens if we get a negative exponent. So if we have a to the power of 5 divided by a to the power of 3, we're gonna get a to the power of 5 minus 3, which is a to the power of 2. But what if we had the inverse, a to the power of 3 divided by a to the power of 5? In this case, we would have a to the power of 3 minus 5, which is equal to a to the power of minus 2. And if we write this out in the long form, a times a times a divided by a times a times a times a times a, and we reduce the fraction, here we're gonna have 1 divided by a squared, okay? And if we choose a different number, so for example, instead of 5 we were to choose 4, we would get 1 divided by a. So the negative sign in front of the exponent means, or the power, means that you have to take the inverse value. So instead of, this would be equal to 1 divided by a to the power of 2. So our rule is a to the power of minus m is 1 divided by a to the power of m. What would this mean? Well, in simple terms, let's say that you have a to the power of minus 2, you'd write, or let's say you have 2 to the power of minus 2, that would be 1/4. And if you had 3/2 to the power of 2 or minus 2, you would first, if you have a fraction, you just switch around the numerator and the denominator. So you do it 2/3 to the power of 2, and that would be 4/9. Okay, so in the same way that this distributes, if there's a product, it also distributes if there's a fraction. So ab to the power of n is a to the power of n divided by b to the power of n. And these are pretty much the main formulas you need to know. There is only one thing that we've yet to use. So here we've used plus and minus, addition and subtraction, my bad. Here we used product or multiplications, and then here we used division as well for a little bit, but that's not very important. But now if we take the actual division operation, so we had a to some okay, or difference. We had a to the power of some product. Now we have, what about if we have a to the power of some quotient? So let's say that we have here n and divided by m. What happens here? Well, this is actually a very unique case, and what we can do to determine is just look at using a very specific product. Let's say that we have 1/2, a to the power of 1/2 to the power of 2. Okay? According to our product rule, this would be equal to a to the power of 1/2 times 2, which would be equal to a. So, what number do we have to multiply by itself to get a? Well, the square root of a. Okay? So this has to be equal to the square root of a. And it turns out that that's the connection. So you take the denominator and that becomes the power of your root. So if you have a to the power of 1/3, you're gonna get the third root of a, or the cubic root of a. If you have a to the power of 4/5, you're gonna get the fifth root of a to the power of 4. So this one remains. The fraction, or the denominator rather, becomes the power of the root. And this gives us a very simple tool to calculate fractions, because you can just translate all of the rules that we determined here to fraction or to roots. So, okay, sorry about that. That was a bit of a technical issue. So we have a to the power of n, or sorry, the nth root of a times the mth root of a. Well, we have the rules now. We just transform them into fractions. So 1 divided by n times a to the power of 1 divided by m, which we then use the product rule. So we have 1 divided by n plus 1 divided by m, which is equal to m plus n divided by n times m. And we get that this is our root. This is our solution here. Okay, so it's actually quite simple. Then we can also just use a to the power of n times the nth root of a times the nth root of b. Well, we just rewrite it again as a fraction divided by n. And that's gonna be equal to ab to the power of 1 divided by n, and that's gonna be equal to the nth root of ab. Okay? So all of these rules, as you can see, are very related, and you just, if you have a fraction, or a root, you just transform it into a fraction and then use the rules that you have here at your disposal. And with practice, you just see that you can use the same rules or how they are related. So for example, with practice, you'll learn that the nth root of the mth root of a, well, that's just gonna be a to the power of 1 divided by m to the power of 1 divided by n. It's gonna be equal to, if we use the power of a power rule, so we have 1 divided by n times 1 divided by m as a to the power of 1 divided by n times m. And so on and so forth. You have all of these rules and they're pretty much related. And that's gonna be it for this video, so I hope you enjoyed it and I'll see you in the practice video. Bye.